So you should be seeing my desktop. So the first assignment was about trying to run Viewphys directly from the command line. So just by typing after the installation, by typing Viewphys, and we can then select a recording. So we're going to select the recording that has been provided for the course. And here what we see is that we see a few hundreds of milliseconds of a recording, the raw data. And the idea was to take control a bit of the GUI, trying to pan left and right, and to zoom. So if you zoom, it's with the right button. It's a bit like Pinpoint in the sense that video game experience can be helpful in order to navigate this properly. After, the idea was to set up the display. So here, to explain what we see, we can see really nice neurons here. And we can look at a trace. We can really see the single trace data for this neuron. You can see that this is a very good firing. I'm going to look at the Q&A. So the idea then was to try to play a bit with the display to put a different kind of color map, so that we can look at the recording. And then is to move along the recording to try to find some interesting part of it. So here, the display is a bit slow with zoom. So that's the new recording. So we can see here, this is a noisy part of the recording. And if we click the describe button, we can have an idea of what is behind a bit those. The idea was then to propagate the display and to show that we can, in order to do this kind of flip display, here we can flip between the describe band and the noisy band. So that's a good way to assess more or less what is the noise, what is the quality of the signal. Do I see some spiking events? With a fast preprocessing, do we see spikes below? Here we can see some interesting signal. For example, you can see those events. It's probably events that are propagating down. So it's probably something that is going down an axon, or you can see this kind of things is going down in depth. One interesting way as well is that we are looking at Neuro Pixel 1 probe. So an idea was to look a bit at the ordering those traces. So here what we are looking as depth, but we can order by column as well. And if we order the signal by column, we have 4 times the same recording, since it's the checkerboard pattern. So that was a bit taking advantage of trying to get familiar with the interface. Here, one thing worth noting is that we did something in order to open a live recording. So if you open a recording with SpikeGLX, you can look at a recording with the same interface, and you can navigate in the previous section of the recording. That may be useful if you want to look at some past part of the recording in a static way, so that it's not constantly updating. I'm going to answer a few questions. The describe and Butterworth button. So the Butterworth button is the default preprocessing with it's the raw data with only the low pass, the low cut filter applied, so that we only remove the DC component of each trace, so that we can look at the data. The describe version is the version of preprocessed data, so that you can see the difference between the two here is that we can see those vertical stripes have been taken out in the describe version. So it's, if you have a lot of noise and you want to look what's under the noise, or you want to look at the quality after preprocessing, it's an option. You have the option to unclick the describe band and to look only at the Butterworth. What's the difference using different color map? It's a matter of personal preference. Some people really prefer the gray. Some people prefer the other color map. Yeah, it's not everyone sees the same things. Some people are colorblind, so it's really about. I don't see lines and dots without distinguishing anything. Do you have any recommendations? Yeah. Can you see the spiking events here? So as I said, this would be a spiking event. This is time, and this is the number of probes. we can see this is a spike, for example. This little blurb. If you move in a trace view, you will have a more intuitive way to look at this. So this is the equivalent in trace view of this density display, and you can see a nice spike that goes down with a nice transient. One thing that was also possible during the assignment is to open that was a question in the Slack. If you want to open the LFP, you can also look at the LFP band. This is possible to look at. So the difference with the LFP band is that we are going to look at 4 seconds of data here. You can see the gain is much higher. And what we can see here in the raw data, you can really see the hippocampus that have very strong signal here. Okay. And it's the same. The idea here is just to check the quality of the LFP. Voilà.
There's another question in the.
Yeah, so the Viewphys GUI works on a desktop. Yeah, so here, this kind of solution, I would really recommend looking to the Spike interface web-based displays for this kind of things. X11 forwarding is going to be quite slow. So you can try and set this up. Here, what we really recommend is a web-based displays. We like both at IBL. We do both. I think both have their advantages and inconvenience. So here I would recommend looking into the Spike interface web-based displays. Another part of the assignment was to look at, this is kind of useful if you want to look at the channel quality, the bad channel detection. And so here the idea was just to read a little snippet of data and to compute and to display the good and bad channel metrics. So this is the same data set. We can see that this is before pre-processing. And here we're computing 3 metrics, one about the dead channel, the noisy channels, and the outside channels. And this view is really to show the thresholds that we applied. And here we see the threshold incoherence is set to 1 and minus 0.5. The threshold on the PSD is set to 0.02. This is important because maybe you can have a data set that exceeds the threshold for all of the traces, and you want to change this as a parameter for your spike sorter. So this is why we set this as a...
Sorry, so just to make sure I understand. So you basically said that you can see what threshold you should use in a spike sorter based on this figure. Okay, that's very
yeah. For IBL, we use the same threshold for all of our recordings, but we had external people showing up with some recordings that were exceeding for example, the PSD threshold for all of them recordings. So in this case, we recommend look at the data in this way to compute those features, to look at the thresholds, and then you can set the thresholds in a different manner for the spike sorting.